Hey everybody, this is Chapter 4, Section 1. The title is Using Graphs to Relate Two Quantities. Starts on page 234. I've got a blank screen here. I want to go through a little bit of background information before I get to the part that's in your notes. You don't have to write this part down, but you do need to understand it because it's pretty much the basis or the main idea for all of Chapter 4. If I have an equation, we've seen things like this, 2x plus 1. Okay? If I have an equation, x and y are related. And what I mean by that is if I change one of those values, the other one will also change. So let's say for a second that I plug in a 1 for x, and I do the math, and I get y equals 3. So if I plugged in a 1 for x, I got that y was equal to 3. If I plug in a different number for x, like x equals 6. If I plug in a 6 for x, I get y equals 13. They are related. If I change x, y will also change. Okay? That is the basic idea for this entire chapter. So, if I go to the first screen, it says a graph is used to represent the relationship between two variables. We just talked about how the two variables can be related. In order to see that visually as a picture, you can use a graph. Okay? A graph has several different parts. You should know these already from middle school. A graph has an x-axis, which goes side to side. And it has a y-axis, which goes up and down. Now, in the last chapter, we graphed things on number lines. Well, really, the x and y-axis are just two different number lines. The x-axis is the number line that we usually use because it goes side to side. And so it's got like -1, -2, -3. And on the other side it has 1, 2, and 3. Okay? So the x-axis is just a number line. The y-axis is also a number line, but instead of going side to side, it goes up and down. So its numbers go 1, 2, 3, and -1, and I ran out of space going down. But it's just two different number lines, and so you're going to be working with these two number lines at the same time. So one of my two variables, the x variable, is represented by the x-axis. So when I go side to side, that's talking about my x number. The other variable is represented by the y-axis. So my y variable is what's going up and down. Each axis gets labeled with the variable that it represents, so that's why I put an x here and a y here. We're going to use this labeling idea more later on in the section. And then a graph should always have a title describing what it's talking about if it's a word problem. Okay, and most of what we're going to talk about today is word problems. So we can use graphs to tell us relationship between variables. We can also use tables. We've used x and y tables so far this year. Okay, you can use tables, and graphs are both showing you how variables can be related. For now, you're just looking for patterns. Okay, if we make a table, and we'll do this in a second, are both lists going up? Are all the x's going up, or all the y's going up? Are both lists going down? Are the x's and the y's both going down? Or is one going up and the other one goes down? Okay. First two example problems. What are the variables in each graph? You remember you had to label what the variables were in each problem. And then it says, describe how the variables are related. Okay? First of all, these words over here on the side, those are the labels that tell me what the variables are in this graph. So in this graph, we are comparing length of a board, if you look at the title, and time. Okay? Those are my two variables. How are they related? Well, time is always going up. We can't make time go backwards. Okay? So time is going up. Time is increasing. What's happening to the length of my board? Well, it starts up here, and after a little bit of time, it goes down. And after a little bit more time, it goes down, and it goes down again. Okay? So the y-axis, when you go down your graph, that means that the value of whatever that variable is going down. So time is going up. Time always has to go up. And length is going down. Okay, that's how those two variables are related. Now, I also put in parentheses here, what is actually happening in this graph? Can you tell me a situation in life where this might actually happen? Why would the length of a board go down? Okay, so you've got a board that's 10 feet long in the garage, and you take a saw and you cut it. Well, what happened to the length of your board? It got shorter. So what's happening here, every time you have a spot where it's straight up and down, that means that somebody cut the board with a saw. So if I was describing what would happen, that's what's happening in this problem. The board is being cut shorter. Let's look at the other one over here. It says June cell phone cost. Don't know if most of you probably have cell phones. So you've got the cost that your cell phone bill is, and then you've got minutes of calls. So the two variables that we're comparing is the cost of your bill and the number of minutes that you talk. Those are my two variables. Cost is actually, well, minutes. Minutes is time. Time always goes up. Now, what's happening to the cost? At the beginning, the cost is staying the same. It's not going up and it's not going down. It's staying flat. Okay? So the cost stays the same for a while. And then, after a certain point, the cost starts to go up. Now, think about your cell phone bill for a second. I don't know if your parents probably pay it, but I don't know if you've ever looked at it. When you use your cell phone, you get so many minutes for your normal price of your phone. So let's say that you pay $30 a month for your phone. Okay, that usually includes like 100 minutes or 200 minutes or something like that. If you go over that amount, you have to pay extra, like 5 cents a minute or something like that. And so what's happening here, the flat part is the minutes that are included in your bill. And then the part where it goes up, those are the extra minutes that you have to pay for. Okay? So, for both of these answers, we have what are the variables, we have describe how they're related, so what's happening to both of them, or what's happening to the variables, and then what's actually happening in the entire problem. The one on the left, the board was being cut shorter. The one on the right, you had some minutes included, but once you got past that, you have to pay extra for those. Okay? You can pause the video here. Whoops, I went too far. Do practice problems 1 through 3 the same way we just did. There's not a whole lot of space here in your little boxes. If you need to answer on a separate sheet of paper and then staple it together, that's fine. Example 2, the table shows the amount of sunscreen left in a can based on the number of times the sunscreen has been used. Which graph could represent the data shown in the table? So we said in the first screen of notes that a graph and a table can both tell you information at the same time. So let's look and see what's happening up in the table. So we're going to say that the number of uses, that's our x variable. The amount of sunscreen, that's our y variable. Okay? What's happening as I go from one x value to the next? So from 0 to 1, plus 1. 1 to 2, plus 1. 2 to 3, plus 1. So it went up 1 each time. Now let's look at my y variable. From 5 to 4.8, I went down 0.2. 4.8 to 4.6 did the same thing. 4.6 to 4.4 did the same thing as well. Okay? It's important that you notice here that the x value always does the same thing, and the y value always does the same thing. Okay? We'll talk more about that in a minute. Okay? Now, remember, let's look here at choice A. Okay? Choice A says that we start up here, and you see how these dots kind of make a straight line? Okay? If your dots make a straight line, that means that your x's and y's are doing the same thing all the way across. Well, that's what's happening in our problem. The x is doing +1 all the way across. The y is doing -0.2 all the way across. So we're looking for something that's a straight line. But where does part A end up? Okay? Look at where the amount of sunscreen ends up. See how this line has a 0 next to it? If you go all the way down to the axis, that means that you have 0. Okay? At the end of the problem that we have in the table, is the amount of sunscreen equal to 0? No. At the end of our table, the amount of sunscreen is 4.4, not 0. So it can't be letter A. Okay? It is a straight line, which is what we needed. Okay? But in part A, it ends at 0. And our table doesn't end at 0, so that one doesn't match. If we look at B, see how these dots make a curve? Okay? A curve means that your x's and y's aren't doing the same thing all the way across. Our y values are doing the same thing. Subtract 0.2 each time. So it can't be letter B because it's not a straight line. And for this problem, we would need it to be a straight line. So hopefully letter C works. Okay? We've got a straight line. Okay? And my last value is up here. It's not down at 0, but it's up a ways. Okay? Now, it doesn't give us any numbers, so we don't know if that's exactly at 4.4, but we know that it's not at 0, so that one makes the most sense. Okay? So this would be our answer. It is a straight line, and it doesn't end at 0. That's how we know that that one works. Okay, pause here. Do the same thing that we just did for these 3 problems. Notice it says match each graph and explain. I explained a little bit down at the bottom. Try these. If you need me to double check them when you get to class, we can do that too. Go ahead and pause and try them. Example 3a. Describe a real-world relationship that could be represented by this graph sketched at the right. And the directions say draw a line from the name of each segment in column A to its verbal description in column B. Okay. Let's look at A and B here for a second. A and B. Okay. Both of them have lines that are going up, right? It's pointing, they're both going in the upward direction. How are they different? Well, A is steeper and B is flatter. I spelled it wrong. My eraser doesn't want to work. So B is flatter, A is steeper. That tells me something. If I'm in a graph, if something happens, if the graph is steeper, that means that whatever's happening in my problem is happening faster. Okay? A steeper line means that whatever that is happening faster. A flat line is happening slower. Okay? So let's look at our descriptions here in column B. Spilling water from a cup, pouring water into a cup quickly, stop pouring water, water leaking from a hole, and pouring water into a cup slowly. So what we're really looking at in this problem is time and the amount of water that's in my cup. So my cup starts with 0 water in it. Okay? And for segment A, it's going up. Now, is it going up fast or is it going up slow? Well, A is steeper, and we said that steep means faster. So A is putting water into a cup quickly or faster. And so that's going to be that match right there. Now, for B, the amount of water is still going up. I'm putting water into my cup, but it's flatter, which means slow. So I'm still putting water in, but I'm doing it slower. So that would be part B. Letter C, if this is the amount of water that I've got in my cup, if water is what's going up and down, is that going up and down at all? No, it's not. So that means that the amount of water in my cup is staying the same. Okay? The amount of water is staying the same. Well, that's probably going to be this one right here. I've stopped pouring water into a cup. My cup has all the water in it that it's going to have. Now, for D and E, both of those lines are going down, which means the amount of water in my cup is getting less. Okay? So for D, that's a steep line. E is a flatter line. So D, since it's going down, that means that the water is coming out of my cup. And since it's steep, that means that it's coming out fast. Well, look at the two choices I have left. Spilling water from a cup and water leaking from a hole. Which one of those do you think happens faster? Probably spilling it out. Okay? For part E, the water in my cup is still coming out, but it's flat, which means it's happening slower. Water would leak from a hole slowly. Okay. Another example, 3b. Sketch a graph that represents the hours of daylight over the course of 1 year. So, we're talking about hours of daylight, and we're talking about a year. Now, those are both kind of times, but we're going to put the year stuff on the bottom. And we're going to put the hours of light up on the side, okay? So when I talk about the year, how do we divide the year up? We divide the year up into months, right? So we've got like January, February, March, April, May, June, July, August, and then December would be like over here, okay? Right now, we've got the time change coming up this weekend. That means that the number of hours of daylight, we move them around.
The following people, please come to the office. Brittany Wishmeyer, Jackson Kane, Morgan Elkins, Jared Stepwich, Mitchell Flynn, Allison Hackman, and Clayton Todd-Schmidt. Thank you.
First of all, are the days shorter in the winter or in the summer? Days are shorter in the winter, so the number of hours of daylight is smallest in the winter. Days are longest in the summer. So we're going to, do we ever have 0 hours of daylight? Now, it might be a really cloudy day and it doesn't look sunny out, but there's always some daylight, right? Especially where we live. So we're not going to start our graph down here at 0 because that would mean that we have 0 hours of light, and that doesn't happen. So we're going to start it up here someplace. And we know that there's more light in June than there is in January. So we're going to go from January up to June. Once I get to the summer, what happens to the length of the day? The days get shorter. So we're going to go back down like that. Okay? So right here, this would be like spring and summer when the days get longer. This would be like fall and winter when the days get shorter. Practice problem 7, you can try this one. Notice it says include labels and a title. So you have to have a title up here. You need to have labels telling me what you're talking about. And then once you put your graph up here in the middle, tell me what's happening in your graph. Like in the last one I told you, well, this is spring and summer and fall and winter. Okay? So tell me up in your graph what's actually happening. Again, if you don't have enough room, you can do it on a separate sheet of paper. Practice problem 8, same thing. Okay. Labels on the side, title.
May I have your attention, please? With all the Brit-Lit boys, make sure that they have their poems in Mrs. Bowman's classroom in the tray by 8:30. Thank you.
And then for practice problem number 9, there's a word problem. They did their graph wrong. Okay. So you need to show the graph correctly over on the blank space, and it says describe what they did wrong. So you can do your description here in the open space. And if you've got any questions or anything that you're concerned about, you can write them in this space right here and ask them about me next time we have, or ask them to me next time we have class.